Today I'll be talking about the outbound REST integration, and I'll explain the differences in one of the slides there. So why do we need a REST integration? So first, the challenge, there's some data. ServiceNow is a great tool, but not all the data is stored within ServiceNow, and enterprises many different enterprise applications. For example, PeopleSoft, it hosts some procurement data, and then some organizations use Workday to host their HR data, but all that data is important within ServiceNow to support certain business processes. For example, if you're trying to make a request within ServiceNow, but we need some PeopleSoft department and PeopleSoft model numbers, we need to import that data into ServiceNow. And ServiceNow is probably not the best place to maintain that data since other systems are closer to that process, but we also don't want to update that data manually. So what do? We can set up a REST integration to grab that data from other systems and transform it directly into ServiceNow. So what is REST? It stands for Representational State Transfer. It's a standard created to allow communication between two computers over the internet. And it can receive data from another system by either making an outbound request or listening on a specific endpoint inbound. And as I mentioned before, today we'll be talking about the outbound only, since that covers the majority of cases that I've had to work with in recent projects. So outbound, just to clarify, ServiceNow makes a request in the external system, and the external system sends the data back to ServiceNow. So here are a few things that you might need in order to set up a REST integration. So first, you need the web service admin role and REST API endpoint. You need to know where you want the data to come from. The external system API should provide you with an endpoint, and usually some well-documented REST endpoints. They will give you some additional information on like the headers and the query parameters that you can apply to the request. And if you can send the request through a mid server. For some organizations, they have private networks which are not accessible from the internet. But the solution is but they have a mid server that's exposed to the internet, so you can have directly send a request through the mid server, and the mid server will basically connect to the private network REST API to grab that response. It's optional, of course, but it's required if there is a private network that you need to gain access to. And authentication. So there are two authentications out of the box, basic and OAuth 2.0 profiles. So the first two you can configure directly within ServiceNow. The third one is also pretty common, and the one that we'll be probably demoing today. It's some APIs provide you with a token, and then you need to specify the token in the header of the request. So that's another way of authenticating the request. So the workflow, so here's a high-level workflow on how this is going to work. So ServiceNow sends a request into the external system. It will wait for the response to be returned, and then ServiceNow will process that response, usually in either XML format or JSON format, and store that data into an import set. We'll go ahead and transform the import set using a transform map, and then we can validate the data. And here I'll show you a quick demo that I built for this presentation here. So we have 3 components for this first iteration of the implementation here. So we have the REST message, which defines the endpoint, request headers, and authentication. And then we can schedule it. So anywhere you can trigger the REST message anywhere that has server-side coding. Within ServiceNow, I've picked a scheduled job just because you can set a schedule on it, maybe trigger every 5 minutes, every 10 minutes, depending on the need. So the scheduled job will basically wait for a response, and then we can talk about async after, process the response, and then populate the import set table. And then transform map will basically take that import set table and transform the data into our ServiceNow table. So I'm in my personal dev instance here. The first piece that we need to set up is the REST message. So under System Web Services, outbound REST message. Here we can create a REST message. I've created one called CoinMarketCap. This is just an API that I found on the internet for this pet project that I wanted to, the goal is to grab the cryptocurrency prices and store them into a ServiceNow table. So the documentation is pretty well defined. I'm using the V1 cryptocurrency listing latest API, this one here. And the API needs a token. So I've created an account, it's free. And it'll give you a token that has, I think, around 500 requests per day. So in the REST message, we can give a description, an endpoint. This is the endpoint that's provided by the API documentation. And then the authentication type. Here, we're doing no authentication because we'll be specifying the token in the header. That's how they authenticate for this particular API. But yeah, if you're the profiles here. And then down the bottom, the HTTP methods. Here, you can define your actual HTTP calls. So this endpoint is actually more important than the parent one, the REST message one. So this is actually the one that's going to be called and can be different for each HTTP method that you provide. The name is the default name, is just the default GET, and the HTTP method. So here are the methods that you can call. The most common one that you will probably use is the GET method, which basically means that you're getting information from an external system, which is exactly what we're doing here. Post is probably the second common, is which you want the external system to act on some information that you're giving it. So if you select post under HTTP request, it should be a content body where you can define that message. And then they have the authentication tab again, so everything inherits from the parent unless you override it. Here, under the HTTP request, here you can specify admit server, the HTTP header. So here is where we have the header. So we have the name of the header, and then we have the value. Here I put it as a variable in which we can go populate at a later time. And the query parameters so I have 3 here at the start, limit, and convert. And all that information can be found from the CoinMarketCap API documentation. Just a little bit note about the variables. So you can actually substitute the value by using this formatted $ parentheses, and then whatever variable that you put inside the API underscore key. When you hit auto-generate variables, you'll create entry down here in the variable substitutions here. So this is, I put the test value, so this is my API key. Don't worry, I'll be changing it after this after this call. But so when you run the tests, so if you, let's say you have like another API key that's regenerated, you can just replace it here, and the system will automatically use the new value in the HTTP header when you're making a request. And variables can be stored in the endpoints, in the headers, as you see here, in the query parameters. And if you're using either a post or put method, any variables defined in the content is valid as well. So let me go through the related links real quick. So auto-generated variables, if you don't have anything down here and you click auto-generated variables, it will point everything with that $ format into the variable substitution. Preview script usage. So this is where you're gonna, it'll give you a sample script that you can paste into either background script or a fixed script just to do some testing. And this is how you're gonna basically call the REST message anywhere you have server-side code. Set the HTTP log level. So it depends on, this sets how much information is stored when you're making an outbound request. By default, it's just basic. Elevate gives you a little bit more information, and all gives you, I think Elevate gives you like the headers and the query parameters, but I need to check the docs on that. All gives you everything basic and Elevate has. And the response as well. So just keep things simple. I'll keep that basic. And then when you click test, it should generate a request into the CoinMarketCap API, and then the response is set here. So here you can see we have a JSON object with the status property and then the data property. So here's all the data that we're getting. You know, Bitcoin, 7,000 right now, and then Ethereum. So we have quite a large payload here. But as you can see, the test is working. So the next step, we basically to schedule it into a scheduled job. Let me go to that. Yeah, so I just created a quick function here to house the preview script usage. So we copy that code and paste it in here. You know, we have to set the stream parameter, the API key, because it doesn't actually automatically pull in the test values. You have to explicitly define it in here. So I've stored the API key into a property, and I'm storing that into that variable and setting it with this piece of code in line 6. And then we do our execute, so that basically triggers a synchronous REST call, which basically waits for the response. And once it has the response, there's a function to process it. Here we put it into an import set. So we create a new import set. We set the mode to asynchronous. So this is a different synchronous, asynchronous. This one means that the import set doesn't trigger right away until it doesn't transform the row right away when you put it into an import set, versus synchronous. Once the row is inserted, it automatically transforms it into a ServiceNow. It runs the transform map immediately after the row is being inputted. So we have the table name. It's a custom table I created in this Asynchronous app. And then just a short description. And then we parse the payload. So there's some payload, parsing here. We set each row of the import set table with the payload, and then we insert that into the import set. And finally, at the last line 59 here, we transform everything after the import set has been loaded up. So let me just execute that real quick. So under system import sets, you can see it's currently being loaded, created just now. If we refresh the list, it should be processed. So we have 500 import set rows. As you can see, some of them are updated since the price, because this price of the cryptocurrency has changed since the last time I ran it. And for the ones that didn't, it will just say ignored, because no field values have been changed. So yeah, it's a little bit more about the transform map. Under system import sets transform maps, you can create a transform map to transform the data from your source table, which should be your import set table, into the target table, which I created, this Asynchronous currency data list here. And then when you can set your field mapping here, and it's pretty basic transform map. It's basically just one-to-one matching. There are no scripting or any other data preparation in here. And here's our final data. So we have, we updated 2 minutes ago because we just ran an integration, but we have about 607. I think is because it doesn't, I just run because of the query parameters that we define, we do start 1 and the max is 500. So it pulls in the most popular 500. And because the popularity list is ever changing, it will give you back different response every time. So there's some extra query parameters that you can specify to get a consistent response every time. So it should limit back to 500 if that's been configured correctly. But not an issue, because the popular ones will probably always be pulled in. So as you can see, everything's good, all that is working, but there are a few things that we might run into here. So we might need to use a mid server if the data is sitting behind a firewall that we can't access from the internet. If the network is slow, if the API server is located very far from you, so they could cause latency issues. If the payload is very large, it could take a very long response time, and the API is not optimized and has a slow response. So all these things can contribute to a slow response, which will hang up the thread and negatively affect instance performance. So basically, after you trigger the API, if it's waiting for a response, that thread is being preoccupied and it can't do other operations. So there is a better way to, if you're processing large data, or if your network is slow, we can do REST integrations asynchronously. So here's a synchronous example, which we just implemented. So you're calling someone on the telephone, asking a question, and then waiting on the line and getting an answer, then getting an answer, and then hanging up. So the whole time you're preoccupied, you're engaging on the telephone. You can't hang up, or else you'll lose your place in line. So you have to wait the whole time. The asynchronous example, you're calling someone on the telephone, asking her a question, but you also give her your name and number so she can call you back with the answer. So the difference here is that you're not waiting while the others are doing their part. And it's much more efficient because you can make many requests without having to wait for a response. And when the API does its work and has a response ready, it'll send it back. So how do we implement that in ServiceNow? So the REST message part stays the same. The schedule job stays the same, but instead of waiting for a response, we will trigger it. We'll trigger the schedule job, the REST message in the schedule job, and just forget about it. And then we'll create an async ECCQ business rule, which will trigger on insert, and then it will process the response. And then everything else should be the same. Populate it into import set table, and then the transform map will take it there and transform it into our ServiceNow table. Yeah, so everything's the same. And here I'm setting a mid server here, and then we, instead of doing r.execute, we do r.execute async. So this fires it off, and you don't have to wait for a response. And I'll show you where the response is here. So if we execute now, that's been fired off. And in ServiceNow, everything that goes through the mid server, it goes through the ECCQ. We can see we have the output that's been processed just now. So that's the outbound going to the Pro API, PlayMarketCop.com API. And then we have the input. The state is ready. So let me refresh it. Yeah, so now it's been processed. So here there are a couple ways that, a couple different things that you might need to know. So if the payload is small enough, which you can set in a property, I think it's, can't remember the top of my head, but there's a property, if it exceeds that size, it'll put it into a payload.txt, but if it's under that size specified in the property, it will just put it directly into the payload. So in this case, our response is quite large. It got dropped into an attachment. So here we have to do some manual attachment parsing to get the actual payload. So let me just show you what the payload looks like. Yeah, so we have the status, the data, same thing as when we did the test earlier, but there's some extra XML structure that we need to parse through to get to the actual output. And the way we do that, so because everything that comes into an ECCQ, so when after we fire the request off and forget about it, and when the response comes back, let's say it comes back in like 5 seconds, which is an eternity in computer world, a row gets inserted here as input, and then we can do a business rule here to listen for that row when it's being inserted. And here you can get some extra filtering down to get to the exact API that you want. And make sure you set it as async, which the thread will run when it has resources. diving into the code a little bit, we have a function to get the payload. So that's either if it has the C attachment, which it has an attachment, it will basically get, you'll parse through the attachment and get it from there. If not, it'll just basically return the payload field from that ACCQ. And once you have the payload, everything else is the same. You parse the XML, and then you process the response, which puts it into an import set table. Just check the time, 3 minutes ago. Sounds about right. 500 rows, and it'll basically, the transform map will run, and looks like everything completed without any errors. 300 updates, 320 updates, and 1 insert. So this is the case, when the payload returns a record that's not currently in our currency data table. I think this should be 608. Yeah, so 1 more, because it's ever changing the whole time. So whenever using mid server, the recommendation is to do an async. To do it the async way, because sometimes you're basically making a request to the mid server making a request to the API, and then API comes back to the mid server, and the mid server comes back to you. So there are 4 different steps going on, and to wait for that to all complete, it just is very inefficient.
Are there any specific debugging tools for that, or you basically just run the call?
Great question. Yeah. So every time you fire off a REST request, it actually gets stored. How we in the REST message we had the HTTP log level, we had the all, elevated, and the basic. So that's actually, there's some logging for let's see if I can find the HTTP for every outbound HTTP request. Yeah. So every time you fire one off, there should be some logging in here. So because the level is basic, it'll give you some basic information here. The source, the request. I think elevated would populate the request headers and the request body, and then all would populate the response headers. But because we had it as basic, the logging is minimal here. But here is where you can see if the request that you fired off is actually the one that you want.
So every time that the request is made, you get data back in, updates the import set table. Does the transform map run every time that happens, or that's part I didn't get? What runs the transform map? Is that just the basic attachment of the map to the import set table?
Great question. Yeah, so the transform map does not automatically run until you trigger it, and we trigger it in our script where we in our business rule for our async example.
Oh, cool. That's the part I missed.
Yeah, so if we go back to the business rule here, under process response, we'll basically set the import set, populate the import set here, and then at the very last row here, this line basically, yeah, it triggers all the transform maps tied to that import set.
Cool, man.
And then there's the order field that you can define for the transform map. It will run in that order specified.
Cool, man. Thanks. Well, also, I had another question. Have you ever done a REST get or put whatever through Flow Designer?
I have messed around with Flow Designer, but it's very limited. So I actually prefer to do it in the native UI. I think there were some issues with REST messages in the Flow Designer, and I wasn't able to get it working. So I actually preferred, I guess you may call me old school, but I prefer using the native UI for any REST integrations.
Yeah, that's what so I just did an application development class. That's basically what I told them. And I was able to get through and get a response. I just wasn't able to parse through the response without also writing a script into Flow Designer. So it kind of defeated the whole purpose of it if you couldn't go codeless. Cool, man. Thanks.
Yeah, you're either doing it there or doing it here.
Yeah, exactly. So
the
do it here or
scripting part. Can't avoid it. Yep.
Cool, man.
Hey, Chris. So I know the async is the way to go, probably 99% of the time. But can you give a real world example of a time when you want to use a synchronous, call.
If you're doing something, yeah, of course. Great question. If you're just doing something really quick, and you don't want to set up the async rule because it's actual development work, then you can actually just do it directly through the synchronous way. But only if you're confident that the API is very strong, that there are no network issues, and you can get a response back very quickly, because you don't want to hang up the thread for too long, which will cause a system performance issue.
Okay, yeah. I was thinking more of a business example where you're creating a service catalog item, you're calling to a third-party procurement system of some sort, and it needs to be, that system needs an answer before the workflow proceeds, or something like that. But I think I understand what you're saying.
Yeah.
So.
Yeah, for any like business example, like if you were doing this for a client, I would recommend async. Yeah, because those are probably all going to be pretty important data that's going to be coming back, and you don't want to have ServiceNow waiting for that. And just because it's async, it doesn't mean it's going to process the response before the response gets back. It will process it once it comes in. So it'll still be executed in the correct order. It just, the thread can be opened up to do something else in the meantime.
Oh, okay. Okay, that answers my question. Thanks.
What's your favorite integration that you've done?
So actually, so this past week we had to integrate with Cisco Intersight for one of our clients, and in addition to the HTTP headers, so they had the authentication is a little bit complex. So they had a public key and a secret private RSA key that's been generated only when the public key is being created. So there's like only a one-time opportunity to get that private key. So both need to be in the header, and not only that, the whole header needs to be signed in a particular format. It needs to be structured in the particular format, and it needs to be signed with the RSA 256 encryption algorithm, and sending all that over to the API, and then you can get a response back that way. So that took quite a bit of time to figure out, because I had to, there's no native ServiceNow encryption algorithm that does that. So we actually had to bring Crypto.js. It's a third-party library from Google, so that a little bit of research had to be done there to bring that in, and then I was able to get the request signed finally. So
okay.
there are quite a few challenges to work through. So, but once all that's done and all the data is flowing through, that felt really good.
That's pretty cool. So you found just like some external JavaScript library, like it's JavaScript native encryption?
Yeah, so Crypto.js is actually pretty well known. It's made by Google, and
did you have to find like ES5 version?
Yeah, so you had to find ES5, and it only works in Scoped app because only Scoped app can parse ES5. And the other challenge with that is it runs in the browser. It's meant to be included in the browser version, so it's expecting a window object and like a user agent object. So there was a little bit of research to be done, so you can actually trick the backend ServiceNow to think it's a browser by adding like var window equals null or equals an empty object, and var user agent equals empty object. So that would make the code think it's a browser, and I was finally able to get it working that way.
Oh, like running it server side?
Yeah, running it server side.
Cool.
Great, thank you for presenting, and I hope everyone has a great day today.